said, usually we like to identify and categorize things in life, don't we? We call some things food, we call some things, furniture, clothing, and so on and so forth. Same thing with numbers, though. We'd like to break down numbers into different categories. Now, here are the different number sets that we know of or humans have made up. So, the first one, it says natural numbers. And again, I told you before, we like to use symbols to define these groups. So this will be an N. Again, I draw a little extra line at the end there. And natural numbers, there's no, by the way, if you look at the internet, there's no actual consensus of what it is. Some people say it starts at 1, okay? Some people start at 0. But anyways, natural numbers are like that, okay? Whole numbers. So whole numbers, we'll use a W, okay? And we'll include the 0 in this case. So natural numbers will be 1, 2, 3, 4, 5, 6, 7, 8, and so on. Whole numbers, 0, 1, 2, 3, 4, and so on. I'm sorry? Okay, integers. What are integers? I told you already, integers are what? Negative or positive? More specifically, what kind of numbers? Whole numbers. Okay. So far we have these types of numbers. However, someone gave me an example before of 0.5. Well, 0.5 is a number, but is not considered in any of these. It is actually going to end up in the rational numbers. Okay. And we use a letter Q here for rational numbers. And I'm going to define it first, and then we'll try to write some examples of rational numbers. So, it's going to be, a rational number is going to be any number that can be expressed as A divided by B. So that's A divided by B, okay, where A and B are integers. Examples of rational numbers. Tell me a number that you can write A divided by B. I'm sorry? 1 over 2. Very good. See? There is a number divided by another number. So that's a rational number. Any other ones? Huh? 3 over 4? Yeah. Negative 3 over 4. That's a rational number because, again, negative 3 is what? Integer. 4 is integer. So, and I can write it as a fraction. Good? Anything else that looks a little bit different from this? Anything else that looks different from these guys? Okay, that kind of looks like these guys. Okay, yeah. Anything that looks quite different from these guys. Huh? Maybe I can't hear because of these things. Hello? What did you say anything? 0.5. Yeah. 0.5 is a rational number, right? It is actually exactly the same as what? A half. 1 over 2 is what? 0.5. Are there any other ones that don't look like any of these? 2.2? Yeah, sure. Or just even simply what? 2. Right? Because I said yesterday, if you have a whole number, you can always put it over 1. Did we not talk about this? Was it my other class? Remember, 2 is equal to what? 2 over 1, you see? So I can write 2 as a fraction. You got it? Okay. So all those are actually going to be rational. It's interesting to know that actually even this is rational. Now this is 0.777777777777777, never ending. Okay, you understand that? Okay, good. So that the repeating part is called the period. Okay, so and that is actually a rational number too, and I'll show you that you can actually write that as a fraction later. Okay, and so some of you are like, okay, what's the problem? I mean, everything seems to be rational then, but actually it's not. But B, something special about B. Aha, very good. B is not equal to 0. Why can't B be 0? Yes. All right, very good. Okay, so let me ask you this. Can A be 0? Yeah, look, 0 divided by 3. And so I could write it as like that, A over B. Okay, and I actually get a number. What number is that? What's 0 divided by 3? What is that? 0, right? You have 0 candies, you have 3 friends, and you're going to give them candy. How many candies can you give them each? Well, 0, because you don't have any. Do you understand that? Okay, 0 candies. However, okay, this is a very sad situation here. Okay, you have 3 candy, but you have no friends. Okay, yeah. Anyway, so how many candies could you give each of those friends? Well, it doesn't make sense because you have no friends, right? Oh, that's bad. Okay, so this one we say it's undefined. Okay, you cannot define that. Okay, so this is undefined. And if you try it on your calculator, you would actually get a, try it. You'll get some error. Yeah, so you get an error. And some of you, I don't know, might go into engineering or programming. If you do end up doing that and you do end up programming, you do have to be careful that you do not divide by 0. Otherwise, they're gonna get the blue screen of death or something. I don't know. Your program is basically gonna crash. Okay. So you gotta make sure you gotta make sure you never divide by 0. Okay. So that is very important. That little part right there. You can write as a over b, but you gotta make sure that b is not 0. And for irrational numbers, we use the same symbol, q, but it's not q. This is irrational, it's not q, so we put a line. And if you go into computer science or Boolean algebra and whatever, you'll see that line there meaning not. Okay, so not q in this case. So can you think of any number that you cannot write as a fraction like that? Other than that one. Do you know there's a special number that you can't write as a fraction like that? Do you know? Very famous number. There's a day for it too. In March, maybe. Pi. Okay? Pi is irrational. And the reason why is you cannot write it as a over b because pi never what? Ends, never repeats. So that's the key there. Never ends. Okay? And never repeats. See, I said here, this guy here, that never ends. Yes? 0.7. Guys, what? Looking? Ben? This one never ends. However, it always what? Repeats. So I could write it as a over b. This one never ends and never repeats. So that is a irrational number. There's another number as well, the square root of 2. Okay, and there are some other numbers. There are some other numbers that are irrational too. All right, so let's do a couple examples. 3 over 6. And remember that dash there really represents a what? Division. Someone look here. You see the dot? There's a number on top. You see the bottom dot? There's a number at the bottom. Anyway. Looks like a fraction, no? Yeah? A dot over a dot? Division? Okay. All you need to do is divide. So, 3 divided by 6. You probably don't need your calculator for this either. But anyways, it's 0.5. All right, let's try another one. Okay, what do you got here? What do you got? 0.4. 2857. Okay, anyway, usually I would like you to round it to 2 decimal places. So do round that number. So 0.43. Okay, so it's approximately 0.43. Is that good? Okay. Okay. Shh. You write a big -2 point. Okay. There's that number. Okay. And then the division part will give you the point something part. What is it? 5, 7. Okay. All right, let's try one more then. Okay. Okay, this is what? Guys, this is what? 3 point something. Okay. One point 17. Shh. Okay. All right, let's go to the next section. Convert decimal to fraction. Now this is a little bit more work. Okay. But hopefully you'll get it. So this is a little bit more work than we did for the other question. But okay, so let's try some examples here. So let's go with A, and I'll put 65. 0.65. So I want to change that into a fraction. Now again, that's decimal, so it is a fraction of 1. Yes? It's a fraction of 1. 0.65. So that's what? 65 over 100. So most of you know that this is actually 65 over 100. Now, there are different ways to do this. One way is to look at it is this. Remember, any number I can put over what? 1. In order to make this a whole number, I have to multiply it by what? 100. In order to make a whole number here, I multiply this by 100. And then that means I needed to multiply what? The bottom one by 100. So that's what? 65 over 100. So that's one way of doing it. Okay, the other way of doing it is 0.65. Okay, you're looking at this. This is what? The 10th, right? This is 10th. This is what? 100th, right? So this number you can put over what? 100. This is in the 100th place, so you can put 65 over what? 100. You got it? So let's do B. If it was like 0.7, what would you do? This is in what place? 10th. So you can put what? 7 over 10. Yeah. If you have C, for example, 0.133, okay, then what place is that last number in? Thousandth. So you can simply put it over what? 133 over 1,000. If you are in doubt, if you did it right, what can you do? What can you do? Just divide it. If you divide it, you should get the original question. Okay. Now, however, I do want you to simplify this. I do want you to put in lowest terms. So how can I put that one in lowest terms? Divide top and bottom by. So yeah, I can divide by 5. What do I get if I divide by 5? 13 over, and that will be what? 20, and that's the answer. Okay, so that's the answer that I want in the end, though. Shh. So again, just understand what this number is. You have how many whole here? How many whole do you have? 2. So you have -2 as a whole number. So the big 2 there. And then you have a fraction part, which is 0.5. How do you write that as a fraction? 1 over 2. I think some of you know that. Or just simply what? 5 over 10. Okay, and then you can reduce that fraction part to 1 over 2. Is everyone okay with that? Yes? Okay. All right, good. In order to do these ordering questions, the best thing for you to probably do, the easiest thing and quickest thing, is to change all of them to decimal numbers. Okay, so change them all into decimal numbers, and then it'll be easier for you to order them. So let me just write down the fraction ones. This one is what? -3.25. A quarter. Remember a quarter? What's a quarter? 25 cents, yes? So -3.25. The other fraction here is -5.3 repeating. Okay. And the other fraction is going to be 1.625. Now let me start ordering them now that I know what they're all, the decimals, okay? So remember the smallest number here, if I'm not looking at this, yeah, which one is the smallest number? Yeah, this one, right? So I don't care what you write here. I'll just write the fraction though. So -16 over 3 is the smallest. And what I'm going to draw here is your alligator eating the bigger number, yes? Right? Okay. So what's the next smallest number? Yeah, -3.25. What's the next smaller one? -2.87. What's the next smaller? -1.4 repeating. Smaller. 0.95. Smaller than 1.625. And that's it. That's all you have to write. Remember, these alligators, you read from what? Left to right. So when you're reading this, you end up at the tip, which is the what? The smaller part, right? So how do you read this? -16 over 3 is what? Smaller than, okay, or less than -3.25, which is less than negative. Okay. Do you understand that? Okay, great. I'm going to show you one more. All right, here's an example. 0.7 repeating. Now, remember what I said before. You can use letters in math. Okay, and then you let those letters equal to a number. And so what I'm going to do is that right now. Okay, I'm going to say, I'm going to let x equal to 0.777 repeating. Okay, so x, when I say x, is going to be 0.777777 repeating. You got it? Okay, now I'm going to take that x. So I'm going to take that x and I'm going to multiply it by 10. Okay? Shh. I'm going to take that x, and I'm going to multiply it by 10. Now, what happens? If I multiply x by 10, what do I get? Does anyone know? If I multiply this by 10, what do I get? I'm multiplying this by 10. What do I get? I have x. I multiply by 10. What do I get? 10 x's. Does everyone understand? If I multiply x by 10, I get 10 x's. Yes? Okay. So I get 10 x's. You got it? So far, so good? Now, if I multiply 0.77777 by what? By 10, what do I get? 7.777 repeating. Now, some of you are like, why do I do that? Well, because if you do this, beautiful things happen. You'll see in just a second. Are you ready? Are you sure? You ready? Okay. I'm going to put x down here. And remember, x is what? 0.777 repeating. Okay? Now watch what happens here. Watch what happens. I'm going to subtract them. 10x minus an x. If I have 10 x's and I subtract an x, what do I get? 9x. Very good. So if I have 10 x's and I subtract an x, I get 9 x's. Okay? Well, notice what I get here. Well, how beautiful. 7.7777 minus 0.77777 actually gives you what? 7. Wow. Just simply 7. Okay? And so, wait, we're not done. That's what 9x is equal to. So I need to, I don't know if you remember or if you did this, but what I do is I divide both sides by 9. Okay? So x is equal to 7 over 9. What did I say x was? What did I say x was? 0.777. What does it say x is now? 7 divided by 9. Do 7 divided by 9 on your calculator, please.